All right, folks, look up here. Let's go over these together. Your CBA is a week from today, and these are similar to two questions that have been on it in the past. For some reason, some kids on number 1 just got stumped, and it's a very simple problem. This set of parentheses really bothered some kids. Are they even necessary? The first set of parentheses is not necessary. Can I take them off? Absolutely. All that's being distributed here is a plus sign. That doesn't affect anything. However, this last set of parentheses does have something being distributed. A negative sign. So you do have to distribute the negative sign here. So the last two terms really become minus 5x minus 2. And I'm going to cross that out so I know I've distributed the negative sign. Then you look for like terms. I've got a 3x squared and a negative 5x squared. Put them together. How much is that? Negative 2x squared. So we're done with the x squareds. You've got a 2x and what turned into a negative 5x. Negative 3x. We're done with the x's. You've got a positive 8 and what turned into a negative 2? Positive 6. You don't want to miss the ones that I would call gifts, okay? There's lots of easy ones on the CBA. That would be a gift. Don't you think that's easy? That's just adding like terms, guys. Well, there's a little bit of distributing, but basically it's just adding like terms. All right, number 2. I would also consider this one a gift. But I still had kids miss it because they found something that looked like it could work, but it didn't. It can't be B. I can tell it's not B because B would give me a negative 2 at the end. It can't be A because A would give me a negative 2 at the end. All right, let's see what C would give you. 3x squared plus 6x plus 1x plus 2. Is that going to be 5x in the middle? No. If you factored this, it factors into 3x plus 2 and x plus 1. That gives you a 2x and a 3x, which does give you a 5x, but that choice was not down there. So what's the answer?
None of the above.
None of the above. Again, I would consider that one to be a gift. It's going to make me very sad if y'all miss one of those types of questions. All right, here's a review from yesterday. Please stop talking. We talked about how to write the equation of vertical and horizontal lines. If you understand the process, these only take a second. So look at 1, 2, 3, 4. I've got 2 horizontal lines for you and 2 vertical lines for you. Write their equations. You cannot just tell me a number. It's got to also have a letter with it. That's critical for these. What? Okay, this is question number 1. Answer it. What is the equation of this purple line here? Question number 2 is the red line. Question number 3 is the blue line. That's what the 1, 2, 3, 4 are for. Well, it depends. No, number 1 is not x equals anything. Number 1 is y equals 4. It's not x equals 4. It's y equals 4. If you forgot that all horizontal lines are y equal a number, then look at some points on that purple line. Look at this point right here. That point is at 0, 4. If you look at the point next to it, that point's at 1, 4. This point right here is at 2, 4. If I go to the left, that's at negative 1, 4. What do they all have in common? A 4 in the y position. So number 1 is y equals 4. The purple line is y equals 4. What would number 2 be then? Y equals negative 3. Every y value on that line is negative 3. Now, up and down lines are different. Those are the outlaw lines. They're the ones that aren't functions. They're the ones where the x's are repeating. So look at the blue line, number 3. What's the equation of this line? X equals negative 2. Every x value is the same on a vertical line. And the green line? X equals positive 1. All right, now, This also comes up quite frequently, knowing the equation of the x and y axis. The x-axis is a horizontal line, like every other horizontal line that we've looked at. The x-axis does not start out x equals anything. What's the equation of the x-axis? Y equals 0. Every point on the x-axis has a y value of 0. 0, 0, 1, 0, 2, 0, 3, 0. All the y's are 0 when you're on the x-axis. How about the y-axis? X equals 0. It's kind of backwards of what you might think. All vertical lines are x equals something. And the y-axis is just a vertical line, so it's x equals 0. Alright, that's a little review from yesterday. Today what we are doing is more domain and range, and from what I've heard from my classes, this is new. Domain and range from a graph. Alright, if you look at this picture, a couple of things I want you to notice. This is called continuous. The reason why this is continuous, it doesn't really go on forever. It has endpoints, but the endpoints are connected by a solid line, or in this case it's a line. It could be a curve, but on this one it's a line. It's continuous. That means there are millions of points on this picture. Some kids are telling me there's only 3 points on this picture. The only reason why I highlighted those 3 points by making a nice big dot here, here, and here is because those are important points for us. They're going to help us find the domain and range. But I could draw dots all along this thing. Okay, it doesn't have to have a dot to show you that it's on the figure. And in fact, most of the time when you are shown these kinds of problems, they're not going to have a nice big highlighted dot for you. It would just be a connected line. Okay, so you've got to know I highlighted it for a reason. Where did this one end? Down here? So that we can notice the left and right edge and the top and bottom, because that's what we need to do for domain and range. But if I asked you to list all the domain values of this picture, that's impossible. Guess how many x values there are in this picture? Millions upon trillions upon billions. There's no way to list them all. Now, what we can do, though, is talk about the lowest and the highest x value. Now, x values, domain values. On a point, the x value does what to your number? Okay, does it go up or down or left and right? The x values go left and right. So if you're trying to identify domain, you want to look at the left and right edge of your picture. The point that's furthest to the left and furthest to the right. That's what you want to do for domain. Now, if you want to put this in your notes, I know it's hard, you can't really draw a grid, but let's just draw the significant points. This point right here is at -5, +3. This point here is at 1, 3. And the vertex at the bottom is at -2, -4. Those are the important points. For domain, you want to look at the left and right edge. And domain is only about x's. So when I'm looking at this point, -5, 3, and this point over here, 1, 3, I only care about the x's if I'm talking about domain. So I don't even bother with the 3's. What's the lowest x value on this problem? -5. Because this stopped right here. It's -5. What's the highest x value? 1. 1. The lowest x value happens right here. That x value is -5. The highest x value happens at the very farthest to the right. This x value is +1. Now, all the other x values are somewhere in between -5 and +1. How do we show that for domain? You've got to write an inequality. -5 is less than or equal to x, and at the same time x is less than or equal to 1. That's how you would describe the domain of this picture. Okay, let's look at it. This is actually saying two things at once. Do you agree that -5 is the smallest? Okay, it is. It doesn't go any further to the left. That's the furthest it will ever go to the left. -5 is the smallest x value. In other words, all of the other x values have to be bigger than negative 5. Well, if you read this from the middle, this is saying x is bigger than negative 5 if you read it from the middle. Do you agree that 1 is the greatest x value? 1 is the furthest point to the right. That's the biggest x value you're ever going to find on this picture. Okay, 3 is not an x value. So all of the other x values compared to 1 are smaller than 1. So all of the x values are between negative 5 and 1. Now, if some kids are confused about what symbols to use here, because this is only one way to write it. There are other ways to write it. I usually write it this way. I usually start with the smallest and end with the biggest. Did you see what I did there? Negative 5 is smaller than 1. Do you agree with that? Another way to write that would be to start with the biggest x value, which is 1, and end with the smallest x value. All the other x's are still between, but I can't use less than symbols. I'd have to use greater than symbols. Both of those are correct. They wouldn't put both of them down there. They'd have to put one or the other. Okay, so that is the way you describe the domain on a picture like that. Okay, now let's change. I'm going to modify this picture just a little bit, so just pay attention to what I'm about to do here. Let's say on the left and right edge, I was to put an open circle instead of a closed circle. That will affect your answer a little bit. What do you think would change? The lines at the bottom, because now negative 5 is not colored in and 1 is not colored in. So it would just look like this. Negative 5 is less than x is less than 1. Does that make sense? What if I went back and colored in the 1? Then I'd have to put that extra little equal sign underneath the 1. So you got to watch out for that. Let me show you a trick they like to do. They want to distract you away from the correct answer on the CBA. And I have seen them do this over and over, and it makes me so sad when kids fall for it. Yes, exactly. I have kids who recognize that negative 5 is the smallest and 1 is the biggest, and they've got to write an inequality, and then they'll circle the answer that looks like that. Why could that never be domain? Yeah, domain should never be talking about y's. It should be talking about x's. Okay, now let's do range. Range is not left and right. Range is up and down, or the top and bottom of the picture. So you want to look at the highest values and the lowest. Here's the highest of the picture. Here's the lowest of the picture. And again, you want to look at the y values now, not the x values. Like there's 2 points at the top. One of those points is negative 5, 3, and the other point is 1, 3. But I'm talking about range now. That means I don't care about the x's, I care about the y's. What's the highest y value on this whole picture? 3. What's the lowest y value on this whole picture? Negative 4. This point is at negative 2, negative 4, but I don't care about the x value. I'm talking about range now. So see if you can write an inequality to describe range. That's the lowest y value, that's the highest y value. All the other y values are somewhere in between. I usually start with the smallest and end with the highest, and I know the y's are in between. What symbol would I use? Less than or equal to, because I started with the lowest. What if I started with the highest? Then I would use greater than or equal to. Either one of those is correct. Most of the time I see it this way, but you never know. They might try to surprise us. This is saying two things at once. This is saying that all the y's have to be bigger than negative 4 and at the same time smaller than 3. It's saying two statements at the same time. Okay, and let's modify that a little bit. Let's say again I put an open circle up here. How would that affect my range? On which number would it just be less than? Is the negative 4 still colored in? Yes, the negative 4 has to have the less than or equal to. The only one that's not colored in now is the 3. I took it off of the top, but I didn't uncolor the bottom. If I didn't want the 4 to have a little line here, I'd have to put an open circle at the 4 as well, and then we would take out that little line. Does that make sense? Okay, look at this, because I did see this one year, and I forgot to show my other classes, where they had one at the top colored in and one at the top not colored in. Okay, so the bottom is still colored in. We're talking about range. The bottom is still colored in. What about the top, though? Would I use less than or equal to? Less than or equal to. Is it colored in anywhere on the picture? Yes, then it has to be included. Even though this one's not, this one is. And that one... What do you mean, what am I talking about? If one is colored in and one is not, you have to go with the one that's colored in. Okay, because you're looking for all the values that y could possibly be. Is y a 3 here? No, because it's not colored in. Is y a 3 here? Yes, so could y be a 3? Absolutely. So yes, I have to include this. Okay, same or similar picture, but now look what I'm going to do. I'm going to extend it with arrows. Y'all stay with me because each situation is different here. Domain. Let's talk about domain now. Domain is all of the x values. Could you list all the x values here? Absolutely not. Because there's millions of them. Okay, then you start, Julian, and don't stop until you're done. All right, now, what's the lowest x value on this picture? Okay, my graph only went to -5, but is this going to the left still? Yeah, the lowest x value doesn't exist because look what it's doing as I go to the left. It's going on for ever. What's it doing as I go to the right? It's going on for ever. That means the domain is all real numbers. So listen carefully to what I'm about to say. No matter what your picture looks like, if you look at the left edge and the right edge and you see arrows on the left and the right edge, then your domain is always going to be all real numbers. What do you mean no dot? Like that? No dot, no arrow, no nothing. We just did just lines. Well, you just have to look at it on the picture. They usually are not going to put nice big dots for you like I did. They usually won't be there. You just have to look at the picture to see where it ends. All right, now let's talk about range of this thing with arrows on the left and right. Range is not quite all real numbers. And it's not all fake numbers either. There is imaginary numbers, yes. No. The imaginary number is the square root of -1. But you'll get to that in Algebra 2. That's not my business to help you guys with. Let's talk about this. Range. Range is the top and bottom. Look at the top. Does it ever end at the top? No. Goes on forever. But does it end at the bottom? Yes. Christopher, are you with me? So this range is not all real numbers. What's the highest y value? Infinite. What's the lowest y value? -4. Okay, so -4 is going to be significant in my range because I never go below -4. So, what happens to all of these y values? How do they compare to -4? Are they getting bigger than or smaller than? Okay, you're saying that this y value way up here at 3 is smaller than -4? They're getting bigger. All of the y values are greater than or equal to -4 in that picture. Because all of the y values are above the -4. It's not all real numbers. It doesn't have 2 endpoints, but it does have 1 endpoint. It doesn't have an endpoint at the top, but it has one at the bottom. We have to talk about that -4. It would be -4 is less than y, yes, that's the same thing. -4 is less than or equal to y is the same thing as y is greater than or equal to -4. That's a 4. All right, let's try some more. A parabola, or in this case, it's part of a parabola. It has two endpoints. Hush, please. Now, if you're trying to draw this in your notes so you can have examples, let's talk about the points that are significant here. This is at -3, -1. This point way up here is at 0, 5, and this point over here to the right is at 3, -1. Is this continuous? Yes. Are the dots connected? Yes. Will they highlight these dots for you? Not necessarily. I also didn't highlight the dot up here at the top, but you just got to know it is there. Yes, because it's on the line. They probably will not highlight the dots for you. The only time that they would is if they're showing you that it's uncolored, if they put a nice big open circle there. But otherwise, they usually just stop it right here. I can't draw very good on this, but here we go. So I have been putting nice big circles, but they won't always do that for you. Okay. Christopher, I need to call your mother again. All right, domain. You try domain, please. Domain is the x values, not the y values. So if you're trying to identify domain on a picture, you need to look at the furthest point to the left and the furthest point to the right. My furthest point to the left is at -3, -1. My furthest point to the right is at 3, -1. And if I'm talking about domain, that means I don't care about the y's, I care about the x's. What's the lowest x value? -3. What's the highest? 3. So I would write -3 is less than or equal to, x is less than or equal to +3. And if I wanted to write the biggest one first, no problem. I would just have to make them greater than symbols instead of less than or equal to symbols. How would that change if I decided to make these open circles here? You would take out the equal sign part if you were to make them open circles. All right, try range then. Range is not left and right. It's bottom and top. Okay, and I've got 2 points on the bottom. One of them's at -3, -1. One of them is at 3, -1. And I've got 1 point at the top at 0, 5. If I'm talking about range, which ones do I not care about? The x's. I don't care about the x's at all. I care about the y's. What's the lowest y value? -1. Both of these points had the same y value. What's the highest y value? 5. So you would say -1 is less than or equal to y, which is less than or equal to 5. Okay, are we good with that? All right, what if I put arrows on this thing? What is? The domain is now all real numbers, because when I look to the left, I see an arrow. When I look to the right, I see an arrow. That means it's forever going to the left and the right. That domain is all real numbers. Range, however, is not all real numbers. When I look to the top, do I see an arrow at the top? No. I see a point at the top. Do I see an arrow at the bottom? Yeah. Okay, so it's continuous as it moves down, but it's not continuous as it moves up. The highest y value right now is a 5. That's the highest y value. All the other y values do what? Go down from there. So how would I describe that? Y is less than or equal to 5. Which, yes, that's the same thing as saying 5 is greater than or equal to y, but they usually write it with the y first. All of the y's of this picture are less than 5. They're under the 5. Okay, let's talk about this situation here. This is important. This is another question that they have pulled out on the CBAs that kids miss for a silly reason. One of these is continuous and one of them is not. Which one's continuous? This one is continuous. That means it has millions of x and y values. I happen to have highlighted some of the nice whole number points. Normally that wouldn't happen. They would just have a straight line segment. I just drew nice little big circles at every whole number point for you. There is a huge difference between when the dots are connected and when they are not. This picture right here is not continuous. What that means is I can literally count all the points. Can I count all the points on this continuous picture? No. Okay, because there's millions of them. I just didn't put dots everywhere, but there's millions of points on that line segment. Now, if I asked you to describe the domain here and you gave me something like this, that is absolutely incorrect. This is wrong because just by looking at this tells me there's millions of x values. There's millions of x values in between -5 and 1. Are there millions of x values here? There's 7 x values here. There's not millions of x values here. There's literally 1, 2, 3, 4, 5, 6, 7 x values here. So in this problem, you cannot write an inequality. If you did, it would be incorrect. If you can count them, you've got to list them. What is this x value right here? -5. What's this x value? -4. I don't care about the y values. I'm talking about the x's. What's this x value? -3. What's this x value? What's this one? 0 and 1. Now, if I come over here to this picture, I cannot list the nice whole number points like I did on the second picture because there's not just 7 x values here. How many x values are here? Millions. Infinite. So for the domain of the one that's continuous, that's where I would have to write that little inequality. I would show the lowest x value and the highest x value and all the other x's are in between. There's a huge difference between those two problems. You try the range now of those two pictures. Alright, on this first picture, the one that's not continuous, you got to list them. This y value is -1. That one's 0, 1, 2, 3, 4, 5. Now, the range on this second picture, you can't do that. You've just got to talk about the lowest and the highest. The lowest x value is -1. The highest is 5. So that would be -1 is less than or equal to y is less than or equal to 5. Okay, so do y'all understand that? So we understand the difference between when you make a list and when you write an inequality. All right, how about domain and range of this one? You do it quickly. Domain should be easy. You just got to glance up there. What's the domain? All real numbers. At the left edge, there's an arrow. At the right edge, there's an arrow. That means all real numbers. Range is not quite all real numbers. It goes on forever below, but it does have a highest point here. The highest y value is a 4. How do all the other y values compare to that 4? They're all less than or equal to 4. All the other y values are under the 4. All right, how about this one? Domain is all real numbers. Range? -2 is significant because it's the very lowest y value right here is the lowest y value. What do all the other y values do? They are greater than or equal to -2. All right. Align. Domain is definitely all real numbers. If I look to the left, I see an arrow. If I look to the right, I see an arrow. How about range? Okay, look at the top. What do you see at the top? An arrow. What do you see at the bottom? An arrow. What's the range? All real numbers. If you see an arrow where you're looking, that means it never ends. It never ends at the left or right, and it never ends at the top or bottom. The y values go on forever as well as the x values. Let me just give you a little hint here, guys. Please listen to this. If you have a line that is not vertical and not horizontal, okay, those two are special. We're going to do some of those in a minute. If you just have a regular slanted line with arrows, whether it's going up or down, whether it's super steep or super flat, all of those have a domain of all real numbers and a range of all real numbers. Any slanted line with arrows has a domain and range of all real numbers. No. All right. Let's talk about vertical and horizontal lines. Look at this line right here. What's the domain of that guy? All real numbers. Look at the left and right. I see an arrow to the left. I see an arrow to the right. The range, however, is not all real numbers. Oh, I keep doing that. The range is not all real numbers. What's the range? Yeah, the range is just 4. Let's look at all of the y values on this line. What's the highest y value? 4. What's the lowest y value? Guess what all the y values are? 4. Anywhere on that line, it's got a y value of 4. All right, I'm not quite done with you. What about this? What's the domain here? Yeah, what's the lowest x value? -1. What's the highest x value? -1. What's the only x value? The domain here is x equals -1. What's the range, however? All real numbers, because the top has an arrow and the bottom has an arrow. Okay, what if I gave you a sideways parabola? Now, it's not a function. Why is this not a function? It doesn't. It fails the vertical line test. So this is just a relation, but we can still talk about domain and range of a relation. Domain, you look at the left and the right. What's the lowest x value? -3. What does it do to the right? Goes on forever. So we would say the x values are greater than or equal to -3, because -3 is the lowest one, and then they just start getting bigger. What's the range? Yeah, look at the top. What do I see? Arrow. Look at the bottom. What do I see? So the range is all real numbers. Even though this isn't a function, it still has a domain and range. All right, your homework is to find the domain and range of these pictures. I'm going to give you I actually made a copy for you guys, so just put your phones away. But if you're watching the video, 1st through 3rd period, this is the homework. What is the only one that will have a list? Number 2, better have a list of numbers. Number 2 is not continuous. I want domain and range.